Now, let us discuss certain special cases in which how this acceleration due to gravity changes. So, now let us discuss the comparison of acceleration due to gravity at the pole and at the equator. We know that what is the shape of the earth actually? The shape of the earth actually it is a spheroid. Spheroid means it is bulged like this, and we know that this is the axis of the earth like that. Here it is the radius of the equator, because this is the equator and this is the pole, and this is the radius of the pole. So polar radius is different from equatorial radius. So let us compare G at the equator and G at the pole. So let us write what is G at the equator. G at the equator will be capital G into mass of the earth by radius of the equator square. Radius of the earth at the equator. And what is G at the pole? Tell me. It is capital G into M into radius of at the pole square. Isn't it? Radius at the pole square. So from here itself we can understand that radius of the equator is greater than radius of the pole, isn't it? Because this length is more when compared to this length. Radius of the equator is greater than radius of the pole. So we know that this G, acceleration due to gravity, is inversely related to radius. So when radius increases, what happens to acceleration due to gravity? It decreases. So if R at the equator is greater than R at the pole, we can say that G at the equator is less than G at the pole. So where is acceleration due to gravity more? It is more at the poles. I hope that you have understood this concept. Then let us calculate the acceleration due to gravity on the surface of the earth. What is its numerical value? So we know that what is G? It is capital G into M by R square. Now we are going to calculate what is the value for G. It is 6.67 capital G into 10 raised to minus 11 Newton meter square, kilogram raised to minus 2. And what is mass of the earth? You know the mass of the earth is 6 into, previously we have done that problem, 6 into 10 raised to 24 kilogram divided by 6.4 into 10 raised to 6 square, that is kilogram meter square. This is it. So while we do this, when we can try it out, while we do it, we'll get the value of G as, we have done the same problem in the previous numerical session. It is 9.8 meter per second square is the answer. So what is the acceleration due to gravity at the earth? On earth, the acceleration due to gravity is 9.8 meter per second square. Now let us discuss the equations of motion for bodies under free fall. So what all are the equations of motion that you have studied in the first chapter? So what all are they? I am going to write it. V is equal to U plus AT. Then what is the next equation? S is equal to UT plus half AT square. And the other is V square is equal to U square plus 2AS. You have the usual meaning for this equation. I'll tell it once again. V is the final velocity, U is the initial velocity, A is the acceleration due to gravity. A is the acceleration when it is an accelerated motion, then S is the distance traveled by the body, then all are given. So how can we apply this equation to free fall now? So let me write the equation. Free fall means it is falling down and it can be going up against gravity also. Some questions can be there asked also. First of all, let us consider what is it is a free fall, that is the body is moving down. We know that the acceleration when under a free fall is called acceleration due to gravity. So while you write this equation, we have to write V is equal to U plus this A turns to be G. We have that value now, right? G is equal to 9.8 and S is equal to UT plus half GT square, and V square is equal to U square plus 2GS. These are the three equations that we have to apply when the body is falling down. Here we can say that the value of G must be positive. Please note it. In the case when we throw up a body, what is it? When the body is getting thrown up, put G as a negative value. So how this equation will become? V is equal to U minus GT. We can apply that equation directly where G is 9.8 only. Don't make it minus 9.8. Already we have included minus here. Then what is S? S is equal to UT minus half GT square, and V square is equal to U square minus 2GS. Here we know that V is negative. That's why it is like that. Thank you children. That's all for today. We will come with more numericals from this session. See you in the next class.